In this episode, let's continue our work in our shader graph to make an effect where the game object can glow around the edges. This makes for a nice effect that's often seen in game UIs when you want to draw the viewer's attention to a specific part of the screen. We currently have a simple shader that can change our material to a solid color. Let's add a little halo or glow around the edges of the game object just to give it some extra emphasis. So here's our current progress. Using the Blackboard in the shader editor, we've exposed this color property in the inspector. The user can then select any color for the material interactively. And that's great. If we wanted to highlight our safety hat object, a nice bright green or bright blue, this very simple shader graph might work just fine. But we want to add a little bit of an edge glow on top of that. So let's edit our shader graph. Double click the highlight shader graph asset in the project if you don't have the shader graph window already open. Now mine's docked already. I'll just maximize the shader editor so we can see what's going on. And here is our super basic shader graph. So let's add some extra nodes to create this rim glow. And we're going to exploit something called the Fresnel effect node to achieve that pretty easily. Fresnel equations were discovered by the French scientist for whom they were named. Augustin Fresnel observed that surfaces, even ones that are not super reflective when you're looking at them straight on, can reflect light really strongly when you look at them at a near grazing angle. If your point of view is almost perpendicular to the surface's normal direction, the surface becomes really super reflective from your point of view. So go ahead and try it yourself on, say, your kitchen table. Look at the table from a steep angle at normal height, and then bend down and look at it from a really shallow angle. You'll see the reflection on the tabletop change a lot as you do that. We know now that this is due to light's wave-like properties. As you approach that grazing angle, when your viewing angle is not quite but nearly parallel to the surface, look at how bright that reflection gets. We'll use a node in shader graph called the Fresnel effect node to recreate this phenomenon, and we'll make a glowing rim or halo around the edges of the game object. Bring up the Create Node menu. Remember, you can either right-click, Create Node, or just use the spacebar hotkey. Either one brings up this dialog, and you can use the filter or just dig through the menus. You'll find the Fresnel effect under Math, Vector, Fresnel effect. And if you knew how to spell Fresnel, you could just start typing in here, F-R-E-S-N-E-L, and don't forget the silent S, it's French. Select the Fresnel effect node, and let's drop that node into our workspace. The node's preview gives you an idea on what the Fresnel effect looks like. The edges of the sphere in the preview glow white, and it's darker in the center. The Fresnel effect has an input port labeled power, and that determines the exponent of the Fresnel equation generating this effect. When you adjust the power to something higher, the rim glow becomes very thin and fine. When the exponent is smaller, the white rim glow gets much larger, and you can make the white almost overtake the entire preview sphere. We already have a base color for the albedo, and the Fresnel effect I'm going to plug into the emission port of the PBR master. And this will effectively show a white rim glow for the emission property of our material. Now once I drag and connect those ports, you'll see the red sphere of the preview start glowing white around the edges. And you can always adjust the power of the Fresnel node and watch the PBR preview update to match. Okay, pretty cool. Now as we work in here, everything that we do is internal to the shader and hidden from view outside of the shader graph window. If you want to expose part of the shader graph in the inspector to allow for user input, we need to make a property on the Blackboard. And that's our only conduit to the outside world of the Unity editor, the Blackboard. So let's allow the user to control the power setting of the Fresnel effect. Now, just as we did with the color, we need a separate node to expose that in the Blackboard. So let's create a new node, bring up the Create Node menu, and we want an input node, so go to Input, Basic, Vector 1. This creates a node that lets you input a single floating point value. When connecting different nodes together by their ports, we have to be aware that not every input port and output port are compatible. Usually you can tell what type of data the port is expecting by looking at the notation in parentheses next to the port's label. For example, the power port has a 1 inside of parentheses, and that tells you that this port can accept the output of any node that has a vector 1, so a field with one number essentially. We just have to plug the output port of the vector 1, notice how there's also a 1 in parentheses in there, into the input port of the Fresnel effect node. Our vector 1 node is currently set to a value of 0, so the preview of the Fresnel node and the PBR master node turn white when I do that. If you adjust the vector 1 value, then the PBR master node will show the rim globe just like we had it before, a little bit thinner and confined to the outside of the sphere. To expose this power float in the inspector, we need to make our vector 1 node a property. So right-click over that and select Convert to Property. You'll see a vector 1 that pops up in the Blackboard. I'll open up the little drawer next to it and default the value to 2.5 or something like that. And let's rename our properties so they can make more sense to the end user. I'll change vector 1 to rim power. And while we're in here, we can probably just change the color property to base color, just so those make more sense to the user. If I save this asset and then go back to the main editor, you'll see that our safety hat object becomes red with a white glow surrounding it. If you check the hard hat highlight matte material in the inspector, you can see our revised property names, base color, and rim power. Adjust those and you should see the results interactively. You can dial the rim power to make the glow broader or narrower, and you can still change the base color to green or blue or whatever you want. And okay, there you go. That's a decent look to highlighting our object. Eventually, we'll make a script to swap out the original safety hat game object for the glowing version of it. But first, let's do a quick exercise and see if we can figure out how to modify our shader graph just a little bit. Currently, our Fresnel effect shows up as white, and you may want to give the user the ability to change the glowing highlight just so it's a different color. We'll do this as a challenge to see how much you've learned so far. And what we want you to do is allow the user to modify the rim color, that glowing highlight, in addition to the rim power and the base color. And that's going to involve creating a new color node and exposing it as a property in the Blackboard. And then we need to add a math node to apply that color to what we've done already. Hook up a couple extra nodes, and you should be able to do this relatively painlessly. So go ahead and pause the video and see if you can figure out what needs to be done here. When you've figured it out, or if you get stuck, unpause and continue to the end of the lecture. Welcome back. In order to let the user control the glow color, we simply need to create a color node. Create node, input, basic, color, and let's expose that as a property. Right click, convert to property, and let's label it rim color. I'll default it to bright blue or turquoise, something like that. And while I'm in here, let's set the base color to green. And now let's figure out how this color node can modify the results of the Fresnel effect. Currently the glowing highlight is white, and to apply our rim color, what we can do is use a multiply operation. If you multiply the color white, which has RGB values of 111 by any color, you essentially just get that color. So there are a bunch of math nodes under Create Node, Math, Basic, and the operator that we want is multiply. So I'll just drop that in there, multiply, and this does exactly what it says. It multiplies one value by another. If I connect the output port of the Fresnel node into the first port that's labeled A on the multiply node, you'll notice that we're multiplying by a default value of 2, and that's that default value already set to port B. And that's why the glow effect gets brighter in this preview node. If I connect the color node's output to port B of the multiply node, look what happens. The color multiplies with the Fresnel effect, And now you see the preview showing a glowing light blue ring instead of a glowing white ring. Notice how the number next to the port changes when I do that. So let's break that connection and I'll show you again. Select the connecting line and right click, delete, and then connect the color out, which has 4 numbers. Remember, that's red, green, blue, and alpha. And we're going to put that into the multiply port B, which currently has a number 1 in parentheses. The instant we let go of the mouse and make that connection, the multiply node is smart enough to know that we need 4 numbers at the top and the bottom. Notice how the 1 next to each port changes to 4 automatically. The color is getting multiplied by the Fresnel output, and that turns our glowing ring light blue. Now, one last step is to connect the output of the multiply node into the emission port of the PBR master. And notice how we're connecting 4 numbers into 3 here. The emission port is smart enough to drop the alpha value, then only use the RGB. And that creates our glowing shader. We now have a separate rim color that can be controlled by the user, and we're defaulting that to a light blue glow on top of a green base color. Save the asset and then go back to the editor. And now you're free to modify the base color, the rim power, and the rim color. And you can change these to anything that you want. Okay, pretty cool. We made some progress and created a glow shader. And we can customize the look of the shader just by using a few properties that we expose in the inspector. All right, so let's continue developing this shader graph. Right now, we're still using a solid color as the base of our shader. Let's see how we can add our glow effect on top of a texture in the next video.